This is Pre-Calculus B, Unit 7, Lesson 2. We're talking about properties of limits. These are properties of limits that are going to seem somewhat intuitive, but they're important. So let's kind of review what the properties of limits are. If you want to find the limit as x approaches a of two functions, or of a constant, actually, this is the first one, of some constant, then that limit is that constant. Okay? In other words, let me go to Desmos here. If I say I have y equals, or f of x equals, a constant like 5, then the limit as x approaches any value is going to be 5, right? Because the function value is always 5, regardless of what x is, right? So f of 2 is equal to 5. F of 3 is equal to 5. F of 9 is equal to 5. It doesn't matter what the function value is. So the limit of a constant is always that constant. All right, so that's important to note. The limit as x approaches a of the identity function, we'll call it x, is a, right? So if I say f of x equals x, and if x equals 3, if x equals 3, then f of x equals 3. If x equals 5, then f of x equals 5. If x equals -2, then f of x equals -2. Doesn't matter what function value you put in, you always get in what you put out. Get out what you put in. You put in a, you get out a. Okay. Then there are these following properties. As x approaches, at the limit as x approaches a of f plus g, where f and g are functions of x, is the limit as x approaches a of f plus the limit as x approaches a of g. Okay? That is, it can be broken up over addition. Subtraction, the same thing. The limit as x approaches a of f minus g is the limit as x approaches a of f minus the limit as x approaches a of g. Okay? The same can be said for products. The limit as x approaches a of f times g is the limit as x approaches a of f times the limit as x approaches a of g. Okay? And the quotient, the last one, the limit as x approaches a of f divide g is the limit as x approaches a of f divided by the limit as x approaches a of g. So it can be broken up over addition, subtraction, multiplication, and division. Okay. And also, well, yeah, I'll leave it at that. So let me apply it to some examples. Okay. Let's say f of x equals x squared and g of x equals x plus 5. Okay, then the limit as x approaches 2 of f plus g is the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x, which is the limit as x approaches 2 of x squared plus the limit as x approaches 2 of x plus 5. Direct substitution works because these are not indeterminate. So 2 squared is 4. 2 plus 5 is 7. 4 plus 7 is 12. Okay? Note that this could be done this way as well. We could directly substitute in the original problem the limit as x approaches 2 of f of x plus g of x. Okay, and directly substitute 2 squared is 4, 4 and 2 and 5. 4 plus 2 plus 5 is 7 and 4. 7 and 4 is not 12. Oops. 7 and 4 is 11. All right. How many were screaming at the camera? Mr. Nozick, you've goofed. All right. So we can apply these to all kinds of rules, all kinds of situations. Let me do just one more. Let's do the limit. The limit as x approaches 4 of f divided by g is the limit as x approaches 4 of f divided by the limit as x approaches 4 of g, okay, which is the limit as x approaches 4 of f, which is x squared, divided by the limit as x approaches 4 of g of x, which is x plus 5. Direct substitute. 4 squared is 16. 4 plus 5 is 9. 16 ninths is just 16 ninths. And again, we could have direct substituted here as well, the limit as x approaches 4 of f x squared over x plus 5. Direct substitute. 4 squared is 16 and 4 plus 5 is 9. Okay? So I know it seems kind of obvious, but basically it's just to demonstrate that we can take, when limits break up over addition, multiplication, subtraction, and division. All right. That's it. Said it would be simple, huh?